So let's start at the basics and actually understanding what is embodied carbon. So if we look at a building having 4 E stages within its life, we can look at the product stage, we can look at construction stage, we can look at in-use stage, and we can look at end-of-life stage. Through each of these stages, carbon emissions will arise. If we break down these stages even further, it's typical that we see the product stage being that stage where we source and we extract raw materials, we transport those materials to a manufacturing facility, and we manufacture and create a product from that. Moving into construction, this is when we bring the products from those manufacturing sites to construction sites, and we construct and actually install those products and materials. The in-use stage is then the stage that we're all familiar with on a day-to-day basis, particularly around how the building is operating. So in terms of how the building is operating in terms of energy and in terms of water. But also within that in-use stage, carbon emissions will arise from how we maintain the building, how we use the building on a regular basis, how we repair or replace or refurbish certain elements within the building. Then as the building comes to the end of its design life, that's when we need to start considering what to do in terms of deconstruction and demolition. And carbon emissions will arise from each of these stages as well, transporting that waste from site and disposing of that waste appropriately also. It's quite common when we see this within the industry that we see letters associated with each of these stages. This can sometimes bring a lot of confusion to people, but essentially these are here to allow us to group all of these stages independently and allow us to actually make sure that when we compare, we're comparing like for like. And this is particularly important when we're setting targets and when we're benchmarking our buildings within the industry. These are typical modules which are set by European standards, both at a product and at a building level. So it's not necessarily a scary thing to see, it's just that it allows us to group our stages effectively. So now that we know the life cycle stages of our building, we can start to understand, well, actually what part of these carbon emissions within this life cycle are attributed to operational carbon and which are attributed to embodied carbon. So what we're all very familiar with is how operational energy and operational water are grouped together to form operational carbon. The rest of the carbon emissions arising from the other life cycle stages, they are life cycle embodied carbon, quite simply. It's important to note, though, that there are a lot of definitions and terms within the industry that people use, and one of those important terms to mention here is upfront carbon. And this upfront carbon is associated to the product stage and the construction stage, or otherwise referred to as Module A. This is of particular importance within the industry because this carbon that we are spending now in terms of producing and constructing our buildings is of greater importance than what we may potentially spend in the future. This is why there's a lot of focus with particularly architects and engineers, with many of you in the audience, will be pushing to reduce these numbers in the first instance. It's also important to note, and something which we'll touch upon later with Kitty and Ding, but this upfront carbon is sometimes what is associated directly with science-based targets, for example. Now, that's not to say that the rest of the emissions in the in-use phase and the end-of-life phase are not important, and actually they are of great importance because rather than looking at the system linearly, we can make the system circular, and that will allow us to reduce our emissions within that product and construction stage effectively if we bring in circularity principles and we start looking at the building industry as a circular system. So how do we actually assess it? Well, we simply assess embodied carbon through a methodology called a life cycle assessment, or an LCA. That's another term which is commonly thrown around in the industry. LCAs can quantify many different environmental impact categories. such as eutrophication, acidification, and so on. But the one that is important to us is the global warming potential, or carbon equivalent, which is of interest for embodied carbon assessments. So a life cycle assessment, well, fundamentally, it's really not that scary. So what we're looking at is just two fundamental things that we need to know about the elements of our building. We need to know how much of a material or a product is going into our building. And then we need to know, well, what is that material or product? What is it made of? And then essentially, what is the carbon factor associated with that material type or product type? And there are lots of different sources where you can get these two fundamental things, but most typically they come from things like bills of materials, extract from BIM software, drawings and specifications, databases, and if we know more about the products which we're actually using, then environmental product declarations, or otherwise referred to as EPDs, which is a little bit like a nutrition label for a material or a product. When we bring these two together and we combine them, we get the most common metric for embodied carbon, and this is kilograms of CO2 equivalent on a per meter squared basis. Sometimes you'll see this also done on a per year basis, and that's typically done in Europe. But this is the metric that you will see your buildings being benchmarked against and being reported against certain targets.